Tale of two Stuart S50 steam engines part 7. Isolating the problem and fixing the leak around the rear cylinder cover by making it a better fit. Machining the piston to fit a silicone O-ring, cleaning some parts with a rotary wire brush, reassembling the engine and setting the valve timing, followed by a series of leak-free test runs using compressed air. To fix this problem, I had to remove the cylinder. The cylinder cover at the piston rod end was leaking all the way around, even after I tightened all of the cylinder cover bolts. Here from the last episode is a shot of the leak in action, and this is when I connect low pressure compressed air to the engine. What can the problem be? Luckily the answer is simple and it's a very easy fix. The engineering standard is too good. The register turned on the cylinder cover is too big to fit in the cylinder without using a hammer. It's what you call an interference fit. Even better than a piston fit, it's very tight. Over now to my Boxford lathe to fix the problem. I'm using a parting tool and I'm removing a very small amount of metal from the register. While I was doing this, I noticed that the bolting surface was uneven. So I ran the parting tool over the bolting face. After a quick touch with some Scotch-Brite, the job was done. And here is the kit of parts that now should fit together. I have to say that the engineering standard on this engine is excellent. A bit too excellent in this area. Now that the cylinder cover isn't as tight a fit in the end of the cylinder, I think now it's going to be steam tight and airtight as well. All I have to do is re-bolt the cylinder cover to the cylinder. I'll offer the normal warnings here. When tightening bolts on cylinders or any bolts on small engines, do not over-tighten them, they will shear off. And shearing off bolts on small steam engines is far easier to do when they are rusty. Now it's time to refit the crosshead to the piston rod, not forgetting to put the lock nut on first. After doing that, I bolted the cylinder to the sole plate using the 3 screws supplied. This clip is out of sequence. I forgot to mention that before putting the cylinder back onto the sole plate, I needed to fit a silicone O-ring to the piston. And while I was at it, I also fitted a silicone O-ring to this Stuart No. 10 piston. You can follow the rebuild of the Stuart No. 10 engine in the series called Rebuilding a Model Steam Plant. I want to show you something quite surprising here. And bear in mind that the O-ring is not a tight fit in the bore. Look what happens here when I try a test fit of the piston in the cylinder. The recessed part of the end of the cylinder, which is the steamway, neatly scrapes off a bit of the piston ring. This is no good at all. You can see the piece of silicone O-ring on my finger. I will put this one down as a fail, but it's not really my fault. There's only one thing for it: remove this piston ring with the Stanley knife and fit another one. And before sliding the piston into the bore this time, I'm using a needle file to take the sharp edge off the port. Now I'm fitting the piston the right way round, and as you can see, it's not a tight fit in the bore. It's just a perfect seal, and it's not been damaged because the edge of the steam port is not sharp anymore. This clip shows me using a rotary wire brush, and there's a health and safety warning. When using rotary wire brushes, always wear suitable eye protection. The stainless steel bristles fly off at a very high speed. And also, it is a good idea to reduce the speed of rotation for this type of work. In this clip, I'm using the rotary wire brush in my Proxxon motor tool to clean up the heads of the bolts. Normally I would fit the motor tool into my bench mount, but I didn't for this job because it was very quick. This job was worth doing because the bolts were quite rusty. And now it's that time again, where I set the timing. The timing was okay before I dismantled the engine, but it's always best to check. A quick test run, and it seems to be running very well indeed. This engine is at the perfect time of its life. It's not been run to death, so the parts are not worn, nor are they tight. Steam engines, like all engines, have a peak in their life. And the engine's performance can be quite different at either side of the peak. For instance, when they went for the world record run using Mallard, it wasn't brand new, fresh out of the factory. It had done some running, it was in an ideal condition to go for the world speed record. As far as I'm aware, after the speed record had been broken, the engine had to be taken out of service for repairs to the bearings on the inside part of the motion. The history books would have been rewritten if the middle bearing had failed at that sort of speed. It would have been the most catastrophic pole vault in history, but thankfully it all worked out well. From the sublime to the ridiculous, from a Gresley A4 to a Stuart S50, from 3 massive cylinders down to just a tiny one. The timing is now as good as I can get it, especially when I slow the video down. And the engine is running very well. So that's it from me. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.